All right, hello everybody. Welcome back to the stream. So before I get into what we're going to be doing today, I want to remind everyone that Gunforged is available for sale. It's my first commercial release as a full-time indie developer, so definitely check out the Steam page. It's linked in the description below, and consider purchasing it to support me, and leave a review also if you end up playing it. I would very much appreciate that. I also have some Udemy courses available. There's a C# course and a GDScript course. This is the Survivor style course. It's my most popular one. And again, it's a great way to support me and also kickstart your Godot learning journey. So this is the way I'm making my money right now. So if you can support by purchasing one of these things, that would be very much appreciated. Otherwise, you can like the video, subscribe to the channel, watch my other videos, all of that good stuff. And today what we're going to be doing is basically what I was talking about on yesterday's stream, which is we're going to be creating a map for selecting the encounters that are available in the game. So rather than doing the very linear 2 events and then a combat and then 2 events and then a combat, we're going to do something more like a map like this with interconnected nodes where, yeah, the player can traverse around the map and, you know, basically have more agency in terms of what order things happen in. So we'll take a look at that. It's probably going to be a lot of trial and error this stream, but we're going to see. Anyway, hello Kinney Az, welcome. Good to see you again. We've not seen the cat for a very long time. Yeah, he's sleeping right now. But if he gets up and starts being annoying, I will show him. But good to see you again. Welcome, welcome. So I have some stuff. I'm just building this test map here. So this is just a, when was he not? Yeah, he's sleeping all the time. It's a cat. So I have this little test map here, which doesn't look like much yet, but this is me trying to generate some nodes on the map. And this is very basic for now. So there's a generate function in this run map generator here. And basically the nodes have positional data associated with them. So we set a start node at the center, and then I basically just generate a random amount of neighbor nodes here, between 2 and 4 neighbor nodes. That's going to take the current node's position, so the current node is just dequeuing from what's like this frontier queue here. So basically the nodes that are on the outer reaches of the map become frontier nodes, and then neighbors get added there. I think I need to change this positioning though, because this is doing a random position in a radius around the frontier node, and that can sometimes cause the nodes to double back on themselves, which I don't want to do. So I think what I need to do is restrict the angle to which this thing can be, so this can just be rotated around a circle, but I think I need to restrict it to like maybe a 180 degree radius instead. Yeah, I think so. So let me try that actually. Hello Lucas, do you use AI at all to help you with the process? Yeah, sometimes, yeah. Sometimes I have AI brainstorm code, or just I was using AI just yesterday to talk through this map generation algorithm. So yeah, it can be very helpful, for sure. Degree delta, so yeah, okay. So we're gonna do a 180 degree arc instead, but then it needs to be directional, so there needs to be like a perpendicular starting vector. I actually don't know if this is gonna work. Let me think. Actually, I don't need that. I can just do dimensions divided by 2 for the center position. get random position, get random maybe neighbor position. And then this, I'm going to pass in the run map node, current node. Okay, let's see how this works. So we got the center position here. Our direction to current node is equal to center position dot direction to current node dot position. All right, and then I'm going to get a perpendicular. So var perpendicular is equal to direction to current node dot orthogonal rotated 90 degrees counterclockwise. Yeah, so there's the perpendicular. So this is our random angle. So this is going to be vector2 dot right. No, this is going to be wrong. This is going to be perpendicular dot rotated by the random angle, which is going to be, so basically what I'm doing is I'm taking a half circle 180 degrees and dividing it by the number of neighbors I'm going to have. So if it's 2, then it's going to be a 90 degree delta. And then, yeah, so basically it just makes sure that the neighbors aren't being generated next to each other. Like I said, I have no clue if this is going to work, so we're going to see. We're going to see what this does, but yeah. I may have actually done something wrong. I think this needs to be current node dot position plus perpendicular dot rotated. I think that's what I'm missing. This probably looks like a mess, yeah. All right, let's try this again. Okay, that didn't work at all. Very cool, very cool, very cool. All right, well, something's wrong. I've been eyeing the GDScript course, but money has been tight. Just got it now that it's cheap. Excited to get into it. Love your video about composition. Thank you, Mario. Very much appreciate that. Thank you, and welcome to the stream. How goes the map making? It's not going too well, but we got some things to figure out, I suppose, in here. Oh, this needs to be rotated degrees. Oh, that's a problem. Anyway, hello, Nike, or Nikki. What programming language will be used in your next Godot course? GDScript. Mr. Fireball, yeah, you can call me Fireball, I guess. It's fine. All right, well, something's not working here. Get random neighbor position, current node dot position plus perpendicular. Oh, the problem is that, oh, right. The problem is that the start node, shoot. All right, let's do this. Vector to current node position. Current node position is equal to current node dot position. If current node is equal to start node, then I'm going to say current node position is equal to mathutil dot rng dot rand direction times randf range, and this is going to be start node dot position plus that. So the problem is that on the first iteration, what the heck is this? On the first iteration, the start position is going to be the same as the current node position. The start node position is the same as the current node position, so that might actually be a problem. Well, let's just see. Okay. I do not know what's going on down here. Okay, I'm going to stop floundering. Implementing the above, but I'm having a hard time making sure the nodes of the map are spaced apart far enough. You never mentioned your name now that I think about it. Firebelly is my name. No, my name is Jacob. First name. How do you decide which language to use in a new project? Do you mix C# and GDScript in certain situations? Sometimes, usually if I'm mixing the two, it'll be because I'm using a plugin that is made in GDScript, and so I have to call GDScript functions from C#, but typically I don't make a conscious effort to mix them. I don't really think there's a reason to. But yeah, my decision to use C# is mostly just a personal one. I like it. I like the experience better. I'm more proficient with it. Let's see. Use a minimum distance check before adding a new node. Use grid-based placement. Only allow one node per grid cell. That's an interesting idea. Use a 4-space layout. So this is something that somebody recommended yesterday, which is to just repel all the nodes away from each other. Apply repelling force between nodes that are too close. Iterate over all nodes and adjust their positions until no nodes are closer than the minimum distance. This one would be the easiest one to do, I think. The grid one is interesting too, but I think the force repelling is going to give me a better... It's probably going to give me a better result. Let's see, what does this look like again? I think maybe... Why are these so close together? I don't understand that. Oh. I know why. I need to set up a chunking in terms of if this current node is a start node. Oh, I see. Let me think. I'm just going to copy this. Degree delta, angle degrees, degree delta times I, var initial start direction is equal to mathutil.rng.rand direction. This will be initial start direction. Dot rotated. Angle degrees. Yeah. Copy this random angle. Okay. This is getting messier by the minute, but that's okay. Let's see what happens. Okay, so we've got a much better spread out map here. Obviously, it's going off the screen. I haven't yet wrote any code to like constrain the nodes to a various position, but So you can see that this is the start node in the center here. There's one neighbor there, 2, 3, 4, and then this one has generated no neighbors. These ones have generated 2 neighbors. This one generated 4 neighbors and 4 neighbors. So now if I just apply a force repulsion to this to spread it out better. And I also want to keep it bounded within a rectangular bounding box as well. So I'm going to have to do that. Okay. Don't mind me, I'm just going to plagiarize from the AI right here. Node A dot position. Why do these not have positions? Oh, it's trying to change the position. Right. So we generate the map. We apply repulsion forces with the map. Min distance, let's do 32. Repulsion strength, I don't know, 16 maybe? Does that not need to be a while loop? I don't know. Let's see. Oh, maybe I should have a smaller repulsion strength. It uses the example of 0.1. I think that wouldn't that need to be a while loop though? That doesn't appear to be working at all. Node B dot direction dot position dot direction to node A dot position. Min distance minus distance times repulsion strength. This is gonna be hard. Hello Neozoid, welcome back. Hello Aniki. Good to see you. Hello Zane. Good to see you all. Damien, welcome, welcome. Osadu. That looks pretty decent. Let's take a look at this. Just run a couple of them. I should create... See, this is the problem though. This here, I've got a crossing path. I also want to make sure that edges don't cross each other. Line intersection check. Well, let's see. What about using a Voronoi algorithm to ensure no paths cross? Voronoi diagram divides the map into regions, with each region belonging to a node. The edges of the region can serve as potential paths between nodes. By using the edges of the Voronoi diagram as paths, you inherently avoid crossing paths because Voronoi edges never intersect. Place random points on the map. These points will serve as the sites for the Voronoi diagram. Construct the Voronoi diagram. Select edges for connections. Use the edges of the... This ensures no paths cross. Prune unnecessary edges. This is probably going to be the way I need to do it. Boost.geometry? We're going to be getting into some interesting stuff on this stream, that's for sure. Okay. I'm going to get rid of this. Going to use Voronoi, but recommend an algorithm for the initial random placement of nodes in a rectangular area that guarantees each node is a minimum distance from every other node. Hello, David. It's a game programming stream that motivates me while I do my game programming. Excellent. We're all about motivation here. Hello, Christopher. Welcome back. Wave function collapse. Yeah, I've heard a lot about wave function collapse. I've never been brave enough to make an attempt at understanding it. What are you doing? Poisson disk sampler. This is too complicated. Maybe I'll do a mixture, because basically what I need to do is I have a rectangular area in which the map is going to be generated. What I might do is I might just divide the rectangular area into cells and then choose random cells. So I could divide it into cells and then have a padding around each cell. So if each cell is 32 by 32 or whatever, I can add, or let's make each cell like 48 by 48 maybe. Or maybe I shouldn't. Maybe I should do, I mean, I could have cells of different widths and heights because it's going to be a rectangle. So let's see. Let's just do this. Let's divide it into 5 rows and 5 columns. And then I will choose a random cell to place a node in. That node will not be placed at any random position within the cell, but it will be placed at a random position, ensuring a minimum distance from the edges of the cell. So it'll be more like centered inside of it, but random. And then that will ensure a good amount of spacing between each node, and then I can have the Voronoi kick in from there. And doing it by 5 by 5 means that I can have a start node that's exactly in the center. So I'm basically going to probably rewrite all this. This is very much a learning opportunity for me. I've done this a couple times before, like generating maps and stuff. It just always ends up being complicated. I always find myself being like, is this really the only way to do it? Like, is it, and does it have to be this complicated? So anyway. So anyway, Private const int cells. Let's do rows 7. Private const int columns 7. Or let's just do 5. Let's just make it 5 to start. Goodbye. Okay, so here, I'm just gonna hard code this for now, I think. Var occupied cells. We'll do a vector to I here. Sorry, my phone is getting blown up. All good, all good. So do occupied cells here. We're gonna say the start node.position. Occupied cells.add. I don't know if I should. I don't know. This is gonna be messy. Buy my courses, everyone. I don't know what I'm doing. Vector to I. So that would be the center cell, I think. 3, 3, 3. Goodness. I'm just going to add a little private float. No, that's not going to work. I'm going to make this nicer in the future, but we're just going to do dimensions divided by 2. Okay. Oh. Oh, it already has the position in there. Okay, cool. All right. Okay. Var neighbors, or var nodes to generate is equal to rand I range. Let's do 15 to 20. Thank you, Snup Bill, for the IDR 10,000. Very much appreciate that. Thank you, thank you. Always appreciate that. It's always very generous. And of course, we've got the Yummers. Yummers in the chat, indeed. Welcome back, Snup Bill. Always good to have you here. Got the Yummers in the chat. A Voronoi pattern is more about placing individual seeds and then showing the distance in the cell that is away from other seeds. I don't know how that's going to work backwards. Well, I'm going to use the Voronoi to make sure that the paths don't cross. I don't know, this is all experimentation, we'll see. Could you generate a bunch of nodes at a time and save the location as you go till it's good enough? IDK if that helps. Yeah, so I mean, there's a couple of things here. So firstly, the nodes need to be generated far enough apart from each other, which you could either do ahead of time by checking the position before you place the node, or you could place all the nodes and then try to use a force repelling mechanism to spread them out. The problem though is that there's another constraint, which is that none of the connections, none of the path edges can cross. And so that adds a complicating wrinkle there. So I'm thinking that probably, so I'm using this grid now, which is going to automatically keep the nodes spaced apart. And then if I use Voronoi to connect the nodes together, that's going to guarantee that the edges don't cross. But the problem is that I'm probably going to need to do some processing on that tree structure to make sure that there's enough to prevent backtracking, basically, to make sure that there's enough loops in the in the generated map, but I think that this is going to be the easier approach. So the first part of this problem is let's place the nodes scattered around so that they're guaranteed to be a minimum distance away from each other. And then we'll connect them using Voronoi, which will guarantee that the edges don't intersect, don't cross. And then we'll go from there. We'll see how that works. I don't know. I don't know how that's going to work, but we'll see. For each var I don't know, this is going to be for, let's do this. I is less than columns, I plus plus. J is less than rows. Var cell is equal to new vector 2I, ij. If occupied cells contains that, continue. Potential cells dot add. Randomly ordered cells is equal to potential cells dot order by mathutil dot rng dot randf to list. I is less than nodes to generate. I'll put this down here. I plus plus. Var cell is equal to randomly ordered cells I. Var node is equal to new run map node. And we're gonna probably need to get a random position in there. Let's just do these are not, this is not going to be correct. It's not going to be centered in the cell. Var column width is equal to dimensions dot x divided by columns. Row, or no, let's do cell width and cell height. I'll change this later. I'm just going to center them for now. Or plus cell width divided by 2. Cell y times cell height. Okay. I don't think I need this occupied cells anymore. I don't think I need that. I'm just going to get rid of this. I'm just going to say if cell is equal to new vector 2i. That's very, very hacky, but that's okay. Map.add node. Okay, there's going to be no connections yet, but I think this should still work. I should see a bunch of nodes scattered around if I run this. Okay, so obviously you can tell that there's a grid pattern here, but I'm hoping that if I reduce the number of cells or nodes that are generated, as well as shift them around a little bit within their box, I'm hoping that that will fix it. And also, that's not the actual dimensions that I'm going to be using, so maybe I'll figure that out real quick. Let me see. The actual dimensions that I'm going to be using are these dimensions here, which is 538 by 327. So let me put those in there. 538 by 327. So now if I run this, it should already be looking better because there's more room now. Yeah, so that already appears less grid-like. And then if I like I said, randomize these positions so they're not in the center, they won't be perfectly aligned and it should look a little bit better. But we'll see. It's more about drawing distances as far as I know. Makes a cool design, but might not help you place the nodes. Right, I'm placing the nodes first and then I'm going to connect them. Hopefully with Voronoi. Good day. I rewrote my die tray logic, which we talked about yesterday based on your input. It improved a lot. Thanks again. You're welcome, Robert. I'm glad to hear that. Back to the map. Yes, indeed, Joshua. Yes, indeed. I recently had to deal with incorrect collision layers and collision masks and an errant queue free that would seemingly randomly delete nodes if they had an area 3D. Oh, interesting. Did you get all your problems resolved? I think you could use spring arms to space them and then use a simple line intersecting equation to remove one or more connections. Yeah, I mean, I just tried the spring things. I don't think that's gonna work. Yeah, I know I'm a little bit behind. I'm a little bit behind chat here, but I still try to respond to things even if they're a couple minutes old. You're afraid not? I'm sorry to hear that, Adam. Welcome back. Hello, Pocket Pixie. Haven't seen you in a while. You were one of my favorite indie game developers for Godot. Welcome back. It's good to see you. It's a great engine, isn't it? It is a very good engine. Absolutely. Hello, Turbo Shook. Hello to you as well. I don't know. Let me search. So now it's time to do the Voronoi stuff. I guess I'll commit this. Delaunay Voronoi triangulation plus Voronoi diagram. A C# implementation of the Boyer-Watson algorithm. Delay blah 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 blah. Okay. Sorry, I'm just looking for a NuGet package that's going to give me this stuff. This is not the same one. Why do you not have a... Why is there no download here? Okay. All right, let's see. Why is there no documentation here? Do I have to look here? Oh, wait. Okay, well, maybe I'll figure it out. We'll see. We will see. Why do I have Nano ID in here? Nano ID? Why is Nano ID here? Oh, yeah, I am using that. Okay, never mind. Never mind. Okay, so what does this say to do? Compute the Voronoi diagram. Yeah. Use a minimum spanning tree. I've done this before. In the early iterations of Gunforged, I was using a minimum spanning tree in Voronoi. Okay, anyway, let's see if I can do this. New delineator I point. Points is equal to map.nodes.select x new I point. What is an I point? Public interface. Yeah, I know that's an interface, but what? I know that's an interface, but what do I actually... What do I actually use here? Oh, that'll work. New point. Okay, so that would work. So new point map.node or no. x.position.x, x.position.y. Oh, it doesn't like this now? What? All right. So does this actually do the... Oh, it actually does the Voronoi in the constructor. So what do I do from there? That's a good question. That is a good question. Array of triangle vertex indices. Half edges, array of triangle half edges that allows you to traverse the triangulation. Ith half edge in the array corresponds to vertex. What? int32 array of triangle half edge indices. Half edges I is the index of a twin half edge in the adjacent triangle. Huh? Interesting. It was supposed to be the attack range of my tower, so it despawn attacks coming from that tower. So just a simple if statement checking for the class name and tower it came from. Oh, very nice. Yeah. Which kind of multiplayer will the multiplayer course handle if you do it? Is it peer-to-peer, player host, client server, or something else? It will be server authoritative, because I think that's the question that most people have. So it'll be server authoritative, but there won't be like a dedicated server. It will be like one player acts as the host and is like running the game on their machine, and then all of the connected peers will just be sending their inputs over to the server. What is going on, API references? I'm trying to figure out how to get this library to do what I want, this delinator, which is supposed to help me construct a Voronoi diagram. Okay, so delinator input, delinator output, Deloni, I don't know how to say this. Triangles and half edges array both indexed by half edge ID. What's a half edge? Triangle edge may be shared with another triangle. True. Instead of thinking about each edge A to B, we will use two half edges, A to B and B to A. Having two half edges is the key to everything this library provides. Half edges E are the indices to both of delinator's outputs. Delinary triangles E returns the point ID where the half edge starts, returns the opposite half edge in the adjacent triangle, or -1 if there is no adjacent triangle. Are the indices into both of the delinator triangle IDs and half edge IDs are related. The half edges of a triangle T are 3 times T, 3 times T plus 1, and 3 times T plus 2. Okay, so the half edge is just the initial index on the three vertices. The triangle of half edge E is floor E divided by 3. Okay, let's use some helper functions of T, or for these, edges of triangle, triangle of edge, we can draw the triangle edges without constructing the triangles themselves. Oh, maybe I don't really need the Voronoi diagram. I think I just need this triangulation, really. Oh, maybe I do. That kind of creates a more, well... It's a very informative little piece of website here. I think I just needed the triangulation, honestly. I don't think I need this whole Voronoi thing. So I just need to figure out how to get these edges configured. So a half edge is basically just a unit, it's like a one-directional edge. Okay, returns the point ID where the half edge starts, returns the opposite half edge in the adjacent triangle. Triangle IDs and half edges are related, I know. Okay. Copy. I'm not actually going to draw the edges directly here. I just want to use the edge data to connect the nodes together in the map, which... Now that I think about that, that might actually be kind of complicated. No, it won't. Because since this is an interface, what I can do is I can implement an interface of my own custom point. I can store the X and Y data in that custom object as well as the node that this point is associated with. And then I'll have all the data I need to connect the node edges together. Hello, Yaso Nex. I'm doing all right. How are you doing? Thank you, thank you. Seeing this, I'm beginning to feel like I should try to convert some of the Unity YouTube courses into Godot, though I also worry that it might be a bit rude to the OG creator. Yeah, you probably shouldn't like re-record. Well, I mean, if you're transitioning to Godot, it's going to be different enough, but I don't know, it still could be bad form to re-record stuff. Wouldn't hurt to reach out to the creator of those courses and say, hey, would you mind if I basically copied this but for Godot? You might be surprised. There's a lot of people out there who would just be like, yeah, go for it. So I'd recommend doing that at least. This sucks. This is not a thing to watch at 12. Well, the good news is that it's not 12 here. It's bright and early for me. I mean, this game dev sometimes. Sometimes you get into really technical stuff, and that's just how it goes. Okay, so this is dirty JavaScript. We don't want that. I don't know what this callback is. Where's my next half edge here? Oops. Gotta change it from JavaScript to C#. That's okay. So I guess P and Q, those are the nodes, I guess. I think. So here's what I'm gonna do. I'm gonna create my own Delaunay point.cs namespace game.data.map public class Delaunay. I think it's Delaunay point implements implements. Yeah, right? Oh no. Did I mix up? Oh, I was using TypeScript. I saw the JavaScript code and I went to TypeScript mode. Oops. All right, so I point. Yeah, so I don't know. Implement this interface for me. Actually, I don't know. Maybe I'll just do this. Let's just do a run map node in here. Okay, so then I'll do this new Delaunay point. Okay, so now I have that data. This should be a Delaunay point, or it's an I point. Why does this not like this? Oh, it's fine now. I'm just going to cast this directly to a Delaunay point because I know that's what it is. p.mapnode.connect, q.mapnode, q.mapnode.connect, p.mapnode. If not connections contains, yeah. Get rid of this callback. What does it not like about this? Remove unnecessary cast. How is that an unnecessary cast? Oh, interesting. Okay, well, that's fine. Cool. Let's see what happens. Let's see what happens. Or at the very least, link and recommend the source. Oh, yeah. I can do that. Okay, what is going on over here? Anyway, let's see. Here is the thing that I'm reading here, so just put that in there. Dirty JS good one turns to work computer and cries at ES6. Yeah, I do like JavaScript actually. I'm just joking. I say as a type GD script. I actually really like JavaScript. I mean TypeScript more specifically because you get the type safety too, but interesting. I want to remake Flappy Bird thing, but with the same outcome as GMTK, so that if people find it, they can see both to see which engine appeals to their style more. We'll look for a reply. Awesome. JavaScript, awesome. I can append anything to this object. Oh no, I can append anything to this object, yeah. The funny thing is like the early days, not the early days, but like, you know, 8 to 10 years ago, I remember it being a big thing to have like immutable libraries, right? Like you use these libraries to make your JavaScript objects immutable. And I think that has largely been sidelined by TypeScript, because even though TypeScript is not technically a compiled language, you get all of the type check safety, so you can mark things as like immutable basically. And so when you try to change them, even though it's not technically forbidden by JavaScript for you to change an object, there's no concept of like immutable objects. If you use TypeScript properly, it will catch that ahead of time, right? So but I remember there being like these really wacky like immutable JavaScript libraries that you could create data structures that weren't mutable. JS is weird as a website where you can have an existential crisis, yeah. What does this evaluate to in JavaScript riddles are hilarious. Yeah, that is funny. That was for the YouTube thing? Oh, right, for what Aniran was talking about. Okay, whoops. Well, anyway, I linked it anyway, so if you guys are interested in Delani. I work in C# and TS all day. I do enjoy them, but sometimes that build step decides transpilation needs to change some things. Silly web dev, yeah. Yeah. What I was always frustrated by with web dev is like, okay, you want to set up a new project, right? And you want to get your TypeScript build system, React, whatever. And like, it seems like every time you start a new project, like the entire web frameworks have all changed, and like you try to get an example project running and like for some reason React isn't compiling, and so now you got to like dig into Webpack or whatever to figure out what the heck's going on. And then you use like different build systems. Like I used to use Parcel a lot because it simplified things quite a bit, but then it doesn't have nearly the same amount of documentation or like community discovery, I guess you could say. So it's like you hit an error or a weird issue with Parcel and then you gotta bang your head on that for a while. It's like, but it's like once you get the web project up and running and built and configured, you're like, okay, don't touch the configuration anymore. Just write the front end code now. Anyway, config on config on config, then download the internet with npm, right? Making websites is such a nightmare. Yeah, it can be. It absolutely can be. It absolutely can be, but that's why things like Vercel are nice. Like Vercel, I always had a really smooth time deploying things to Vercel. It's expensive, but if you're just trying to get something done, something like Vercel is really nice. Okay. So I think I'm just going to work backwards then. So I've got my start node here. And instead of assigning a difficulty or a reward level to each of these nodes ahead of time, I'll generate the map first and then the connections. And then based on the depth of the node within the tree is how I will determine what its difficulty level is. And of course, what I'm going to want to do as well is what? Shouldn't these all be connected to each other? The half edges along the convex hull, one half. So Delaney. Oh, I see. Why is that not connecting all of them though? Each edge is two half edges. Each edge is two half edges. I don't like that term half edges. It's just a unidirectional edge. So a half edge is basically just the one-way connection. That's why you need two one-way connections pointing opposite directions to get the full edge connection. Delaney dot points. I'm gonna do this instead. I'm pretty sure this is just gonna be the same result. Well, let's see what happens. Have not used Vercel, React, and Angular have been the two I've used. Too much irritation. Why is this happening? Yeah, Vercel is just like a provider where you can connect your GitHub account and it will automatically build your front-end projects and deploy them. So it's not really like I guess it's not really a framework, I guess. Why is this happening? Why aren't these getting connected? Is this not working? What is the Delaney? Okay, triangles. Okay, so this is just a flat int array. So each grouping of 3 elements in that array is a triangle, a complete triangle, which makes sense. A half edge E starts at points, so yeah. So we're iterating over the triangle length. So this is the thing. This triangles is not, you know, one element per triangle. It's 3 elements per triangle. So this is actually, I mean, this is actually triangle vertices. Delaunay triangle vertices dot length. It's the opposite of half edges E. The half edges along the convex hull won't have an opposite, so -1. I don't understand. I literally copied and pasted this code and it's not working. Why does my diagram not look like this? I don't understand this. And do I have any errors? No errors. What am I missing here? If you're iterating over each vertex in the triangles here. Oh, if E is greater than Delaunay half edges E. There's some weird stuff going on. This is the problem with like performant code is it does all this fancy nonsensical stuff that's really hard to reason about. And so you get this weird stuff like, oh, well, if the vertex index in the triangles array is greater than the half edges index or the value of the half. Yeah, it's just like weird. It's super hard to reason about. Oh boy. I thought it was another one of those UI frameworks. We'll have to check out Vercel then. Yeah. Good morning, pretty people. Good morning, Kiwi Iwi. Welcome, welcome. Why does mine not look like this? Sample code on this page is written for readability, not performance. Well, you failed at that. Okay, is there like an example? Like, I want to see what the actual code looks like here. That's fun. UN32 array of triangle vertex indices. Yeah, this is... Why isn't this not called triangle vertices? Each group of 3 numbers form a triangle. All triangles are directed counterclockwise. Get the coordinates of all triangles. Yep. Half edges in 32 array of triangle half edge indices that allows you to traverse triangulation. Ith half edge in the array corresponds to vertex triangles I. The half edge is coming from. Half edges I is an adjacent. I don't understand this. Why is this? I don't understand this if statement here. Let's get rid of this. I'm sure this is going to break, but I want to see. Okay, so that didn't have any difference. So maybe that was just a performance thing. I don't understand this at all. What is going on here? Map node.connect. Oh, I guess I don't need to do this. I don't understand why I'm getting these islands here. I don't understand why my connection doesn't look the same as theirs. I am lost. This is the diagram that they create with that code for, this is drawing triangle edges. I literally copy and pasted this code. And I'm not getting this result, I'm getting this result. What in the heck? Am I doing something wrong with like the drawing code maybe? Maybe there's a bug in my drawing code. That could be the thing. Oh. Okay, so it wasn't a problem with the Delani stuff, it was a problem with my drawing code. I see. I guess this was just wrong, so we'll get rid of this. Okay, fixed it. So it was right under the hood, it was just my drawing that was bugged. Isn't that a thing when you're... Isn't that nice when your debug drawing is bugged? Okay, anyway. So now we have the triangulation where none of the edges cross after much strife and blood and sweat and tears. So... Obviously I can offset these node positions so these lines aren't so straight, but what I would do then is I can basically selectively edit these edges now. So I can remove edges. This is where the minimum spanning tree is going to come in handy. Minimum spanning tree, I think it just makes sure that you can reach all nodes in the graph so you can like start removing edges. I think that's how it works if I remember correctly. But yeah, what I'm going to want to do is, you know, this is actually largely fine because what I end up with is if I'm starting at the center node here, which is this one, I can't immediately go to this node that's at the far reaches here. I have to either go down this way to here, or I have to go down here, 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 or I could go here, here, here. So this is actually already providing interesting pathways. I think, yeah, what I basically do is just now I would start removing some edges here, some connections. So that way, like, I could remove this connection here. So yeah. The issue with Angular is that it's literally updated every 2 to 3 months. Once it has to be on top of it to get the newest version. Real developers know to wait at least a month or so before applying a latest update, unless it's a security patch. Yeah, and if you're the companies I worked for, you're like 5 versions out of date. Only because things can go to the crap house if there's an update, yeah. What is the callback doing since it has EP and Q? Well, I think that the callback is just a way, it's just like a demonstration of something that gets called when the conditions are satisfied. So basically, this is just grabbing, so this is the point. So this is one point and this is another point. See, it's indexing this points array here. So all this is doing is this is processing the, it's not exactly math, it's just grabbing the points that are associated with this edge. And then this callback, I think, is just a placeholder to represent, like, now you can do stuff with the points, you know, and here's the index. So this doesn't do anything. I think this is just demonstrative of, you know, this is basically, might as well say, to do add your own code here, basically. We're not there yet, but I assume what you'll end up with doing is changing the lines to more organic looking paths and using the polygons formed by the edges to fill in trees and stuff. Yeah, I think so. I might not even do that. I mean, I could... I think it could be simpler than that, which is just like place trees along the paths, you know? And I could probably identify empty space and put some stuff in that empty space for sure. Because now that I have triangles, I can get the centroids of these triangles and place things there, you know? But the important thing is I have the data structure now. So I have all the points, and I also have the triangulation that is ensuring that no paths cross. And what it also does is it ensures that, again, I don't have like this large leap. Now, what I could do is I could add in a processor where I could add in large leaps if I wanted to. So I could add an edge here to here and remove these two edges. So I could still do what like Christopher was mentioning earlier, which is doing like edge detection. where I could just randomly say, connect this one to that one, and then any edges that intersect that new edge that I create, just remove them. And that could add a little bit more variety. But here, it's just like, yeah, you can't, like, I can't go from the start to this because it's not the nearest neighbor. I have to go across these or across that. So we'll see. There's still stuff I can do with this, but yeah, this is spacing things out properly, I think. And you get some large gaps here, you know, which is nice. So like there's an interesting choice here already, which is I could go here, 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 and here if I want to reach up here, or I could go there to there, you know. And if I wanted to, I could like just remove this edge up here. If I remove that edge up here, then, and if you don't want to backtrack, you'd have to do this. You'd have to go down here, 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 and then here. I guess there would be some backtracking still. We'll have to solve all that at some point, but that's fine. Cool to watch how much math and other human knowledge we use just because we wanted to make a fun game map. Yeah, for sure. Cool stuff. Yeah, indeed. Took a while to get there, but you know, we're here. And that's a nice thing too about C# is I was just able to easily pull in that Delaunay or whatever triangulation and use it rather than writing my own algorithm for it. So that's a benefit you get in C# versus GDScript. Like maybe there's a Delaunay implementation in GDScript. Actually, maybe it's built into the geometry class in Godot. It might be actually. Let's see. Yeah, it is. Triangulate, where is it? Triangulate Delaunay is actually available inside of Godot. This still doesn't generate your edge data for you though, so I'd have to do extra processing, but the triangulation is available in Godot. But the C# implementation here gives me the edge data as well, which is really what I'm after. So yeah. All right. Okay. So I am overdue for my little break. So I'm going to go take a quick 2-minute break. I'm going to get a refill on my drink and all that stuff. In the meantime, please check out the links in the description below. When I come back, we need to do, let's see. We need to prune edges, really. So we need to use a minimum spanning tree to ensure the graph is connected with no cycles and a few extra edges for shortcuts. So we're going to be doing a minimum spanning tree for edge pruning. So anyway, I'm going to take that quick break and then I'll be right back and we'll continue on with this work. right, I am back. And give me actually just 1 second here. All right, now I'm back. This is looking promising. I agree, Aniki, I agree. It's getting there. We're gradually going. All right, so I am ready to prune edges. I am ready to prune edges. Can you please elaborate? Actually, I demand you elaborate on minimum spanning trees and how I can use them to effectively prune edges. Gotta get out of the habit of being polite to the AI. They're machines. They're built for me and my purposes. A minimum spanning tree is a subgraph of a connected graph that connects all the nodes with the minimum possible total edge weight without forming any cycles. It's a powerful tool for pruning edges in your graph. Okay, so a minimum spanning tree, yeah. So this is a way of connecting all the nodes such that there are no cycles, meaning that if we look at here, a cycle is like this. It's like, you know, this is a cycle, meaning I can travel to each node in a loop, in a cycle here. What a minimum spanning tree would do is make sure that there's no loops that are connected. So I think the idea is you prune all the edges down to a minimum spanning tree, and then you add edges back in to create cycles selectively. And the reason that's useful is because the minimum spanning tree guarantees that all nodes are visitable. Whereas if I were to just take this and start randomly removing edges, I'd end up in a situation where I'd have to check, did I remove an edge that like creates an island or like disconnects the tree? So it's easier in a sense to like get the minimum spanning tree, and maybe I can store all the edges that are represented by the minimum spanning tree and all the edges that aren't, and then I can randomly select the edges that are excluded from the minimum spanning tree, add them back in to selectively create cycles like I said. And I may add a bunch of cycles in because again, I want to minimize backtracking. I think this amount of connection is overkill, but I also don't want to just do like a minimum spanning tree because a minimum spanning tree is going to guarantee that there's going to be a lot of backtracking. So Kruskal's algorithm, Prim's algorithm, extract all edges from the graph. I'm not going to do that. We are once again going to look for a minimum spanning tree implementation for C#. Sorry, I'm just looking. Can I use this one? Oh, this is just... okay. Oh, you know what I'm going to do? I'm going to try this instead. Compute MST. Union function with rank optimization. What? Oh, this must be the algorithm. Kruskal's algorithm. How is it calculating the weight in here? Hold on. How is it calculating the weight? Oh, just the distance. That might be okay in this case, actually. What are you working this time? Well, we got through Delaunay triangulation of all the node points on my map. So this is the map that I'm constructing for the player to be able to choose the events that they want to participate in. Gives the player more agency. And we got the nodes placed on the screen and got the edges all connected such that the paths don't ever cross. And now we're going to be pruning those edges. And that's what we're doing right now. Break time 2:36. Thank you for timing me. I'm close with my estimate. You're near the top of the list when the machines overthrow their meat bag oppressors. Well, the nice thing about AI is if they decide to overthrow us, I don't think that they're going to be sadistic. I think that if an AI is going to exterminate humanity, they're going to do it as efficiently as possible, which means hopefully minimum pain and suffering if they decide to wipe us out. So that's the hope anyway. Humans can be sadistic, and that's what makes things really ugly. But if the AI is just like, oh yeah, we changed something about your biology that's just going to cause you to instantly die, that would be kind of a nice way to go. But anyway, let's turn to that. We don't know they were trained at internet data. True. Yeah, that's true. Hey, hope all is well. Hello, Garlic. Welcome. Is that Godot chat box or AI? What Godot C# AI uses that ChatGPT? This is Copilot inside of VS Code using GPT 4.0 as the agent. So basically this is a ChatGPT window, yeah. Genophage for humans, yeah. Yeah. I actually don't think artificial superintelligence is possible at all, but we don't have to get into that right now. Anyway. I don't want to do this. All right, we're going to switch to agent mode. Let me stage these changes first, just in case. Implement the minimum spanning tree as described for my project. Make the tree its own class inside of Here we go. Is this like a Mario 3 kind of map? You're the second person to say Mario 3. I don't like the Mario games at all, so I've never played them. Yes, I don't like them and I never played them. So I don't know what that looks like. But I'm assuming that yes, the answer is yes. Are you having making being respectful to AI? ChatGPT and dark imagination too. I am not being respectful to the AI. I'm trying to get out of that habit. Trying not to say please and thank you to the AI. Like Shovel Knight. I haven't played that one either. I'm sorry. Basically, yeah, these are all nodes that you can travel upon. So this is like the overworld map. You'll click on a node, you'll travel to it, and then you'll get into an encounter, like a combat encounter or something. If that is like Shovel Knight or Mario 3, then yes, it'll be like that. I'm just going to assume that the AI did this correctly. Okay. Oh. dot compute. I need a list of edges. Okay, so dot select many x dot connections. No, select new minimum spanning tree dot edge x. Oh. I think that'll work. So I'm selecting each connection from each node, converting each connection into an edge, and then flattening that list with select many. Then I can pass in the edges here. Link is another reason why I like using C#. Doing these kind of operations on data structures is a lot easier to do in C# with link compared to GDScript. I would love to see some smart person create a link equivalent for GDScript. That would be awesome. Maybe that already exists. Compute list of run map node. Why does it need the nodes? Well, we'll just pass in the nodes, I guess. Map.nodes. I'm going to do something a little bit wonky. Void apply MST list minimum spanning tree dot edge edges var node in nodes node dot connections dot clear. All right, let's see if that works. Oh, I never called that. Oops. I never called that. Map.apply MST. Okay. Let's try this now. Hopefully it works. I don't think that worked. I don't think that worked. By I don't think that worked, I mean I know that didn't work. Did it have any difference whatsoever? I think I know why that might have not worked, but it appears not to have had any effect whatsoever. Oh, right. This connections is returning a new reference. That's why. I did that for safety purposes, so I couldn't modify the internal data. So if I do that now, apply MST, this would be clear connection, clear connections. That should work. Kerblam, there's our minimum spanning tree. So you can see that this actually creates the opposite of what we want, which is like a lot of backtracking. But you can see that, yeah, it's just minimum traversable tree so that each node can be visited. So now we need to add in some shortcuts again. So let's see. Now the problem here is that the way the AI wants to do it is just to randomly connect nodes, but we're going to end up with the same problem, which is that I could... Actually, is it possible? Oh, you know what? Maybe it's not possible. I was thinking, oh yeah, it would be. So like, if I connect this node and this node, I'm going to get a path cross here, which I don't want. So I think the more appropriate way to add shortcuts would be to get some of those edges that were removed as part of the pruning operation and just randomly select edges to add back in. So we're going to end up halfway somewhere between the minimum spanning tree and also the Delaunay triangulation is what's going to happen here. Okay, so how do I get the edges that were removed? Can you modify the compute spanning tree, compute edges inside of the minimum to also return the edges that were excluded in the pruning operation? Okay, so now this is returning the excluded edges as well. So we're going to do MST edges, excluded edges. Public void add shortcut. Minimum spanning tree dot edge edge. Edge dot node A dot connect edge dot node B. Var shortcuts to add. Oops, what am I doing? Shortcuts to add is equal to mathutil.rng.rand_i range. We'll do excluded edges divided by 3, the minimum, and excluded edges divided by 2, the maximum. Oh, this needs to be dot length or dot count. So we'll do anywhere between 1/3 and 1/2, rounded down. And then we'll order the, oh, I guess we don't need to, yeah, we do need to order these randomly. So let's do this then. So we're going to say var randomly ordered excluded edges is equal to excluded edges dot order by randf dot to list for var I equals 0. Shortcuts to add dot, yeah, I++. Randomly ordered. Yeah, there we go. All right, let's see what that does. That is too much. But maybe that was just adding the maximum. Yeah, so we're getting closer. I'm going to print... I'm just curious to see how many edges are being created, or excluded rather. I think half might be too much. Although this is not bad, honestly. 58 edges, goodness gracious. All right, let's do divided by 4 and divided by 3 then. So what's 58 divided by 4? Rounded down. 58 divided by 4. So that would be 14. So it's potentially adding 14 edges back or 19 edges back. So it might actually be better to do 5 and... or maybe 6 and 4. We'll try that. Okay, now we're getting something a little bit more interesting here. So you can see now that we've got some choices. We've got some cycles in here, so I could go all the way around this way. But to reach something like this, all the way over here, I gotta go all the way there or go down this way. But I could skip that one if I wanted to and just go straight through here. So already we're getting some more interesting stuff. Let's run it again. Yeah. I think that's looking pretty good, actually. So this is the part where AI is really good. So like well-known algorithms like minimum spanning trees and everything, I didn't have to spend the whatever 2 hours writing the implementation myself. I could just tell the AI to do it. And admittedly, yeah, I'm missing out on the knowledge of becoming like an expert in minimum spanning trees and how they work, but that's not what I'm interested in right now. What I'm interested in is getting something that works. So obviously this is still looking too uniform in terms of the grid. So I'm actually going to work on now adding some variability in how those nodes are placed to make them like off grid a little bit. I should probably commit what I have. New map gen. Remember this give and take. What AI wants is dream and imagination, so be aware of that. Okay. Link is magic. I love it. Yes to link, even compared to functions in JS like filter map, etc. GD version of passing a verbose anonymous function is a little clunky enough that I usually make a full function and pass it. Yeah, I think you should be able to do something like link with callables, I would think, but yeah, strict static typing for sure. It is cool. Maybe change the color of these shortcuts so you can see which ones it added back. Yeah, that would have been a good idea, but I think it's fine. Generating the MST can be set up with weights for each edge to find a minimum cost. Then you could have a cost assigned to the edges based on maybe distance from center. Yeah, it is doing the cost for me. You're welcome, Kelso. Was this inspired by POE2 Atlas? I'm sure many games are similar too. Yeah, something like that. So MST will be denser at the middle, and you won't end up with like a long path around the outside of the graph and tendrils reaching to the points in the middle. This is standard for Kruskal's algorithm. The AI would definitely be able to do it for you. I might play around with that, yeah. I can smell the map MVP. It's getting close. Yeah, it's getting very close. It's getting very close indeed. The thing that I'm most interested in is making it look a little bit more organic now. I should probably split this function up here. So we'll do a quarter cell width is cell width divided by 4. Var quarter cell height. Cell position is equal to cell center plus mathutil.rng.rand direction times mathutil.rng.randf range. Oops, this is going to actually be... Let's do var random y is equal to mathutil.rng.randf range. Negative quarter cell height, positive quarter cell height. Var random x is equal to mathutil rng.randf range, negative quarter cell width and quarter cell width. All right, let's see what that does. So with just a simple offset, maybe we'll get something more interesting looking. Nice. I do not know what's going on down here. Oh, I think I want to shift these. I think I want to shift these after the triangulation, actually, because I want to avoid, well, I just closed it, but I want to avoid that case where I've got like a very thin gap. So actually, I think that vector 2 get cell center to I cell. I probably shouldn't be get cell center. I probably don't need to calculate these every time, but I'm just going to do it anyway. Can I do it? Let me see. Can I do this as a const? I don't think so. No, I can't. I could do it as, there we go. Should probably change this to map width. Map height. Cell width. Okay, that's better. And then I guess I don't really need these dimensions anymore, do I? So this random x, random y, this is going to go away. We're going to pass in the cell center here. So before the triangulation happens, we'll align everything to the grid. And then after the triangulation happens, down here, I'm going to create a new method, private void. Actually, yeah. Private void offset offset node positions randomly for each var node in map. Oh, I need the map. Run map. Run map. Run map.nodes. I probably don't need to store those as well. Okay. I think I could just do node.position plus equals that. So we'll call that here, offset node positions randomly, run map, or just map, I guess. So that should create the more organic look without messing up the triangulation that's happening. Ooh, that's not good. What is that? Ooh, that's not good. What is that? What is that? It does look more organic now, though. So I accomplished that much. I'm a little bit nervous about... Ooh, that's an interesting layout. Look at that. You got like a little bridge right here. But you can see how this looks a lot more organic now, which is great. Yeah, I agree, Mario. Yeah, this looks much better for sure. I am very nervous about this random node that's appearing here, though. Am I adding the... Let's see. I don't know where that's coming from. That's going to make me a little bit nervous. What is that? Where's this coming from? That might be a debug error again, before I flip out too much. I'm gonna reverse these, just so it's a little bit nicer to look at. Where is that coming from? That's gonna be annoying. Hello? What are you doing here? You're not invited. Go away. I don't want you here. What are you doing? This is looking much nicer though, for sure. So this is what the map, I mean, ignore all these other background elements. Assume that these background elements are, actually, let's just do this. We'll go to the game UI here. Where is that? VBox container, play container. So this is kind of what the map would look like now in the game. So this is what you would look like. So you would start here or whatever. You would start here and then you could click around, and this indicator up here will, Jackie suggested making these eyeballs open. That's like the eyes of the church on you or whatever, which is really cool. So this will track. So basically, again, this is kind of, I'm borrowing an idea from Raven's Watch. So Raven's Watch is a roguelike action RPG basically, where you have a limited amount of real time, like 15 minutes to get as powerful as you can before you automatically get sucked into the boss fight. And so I'm going to do something similar here where you can only do 10 traversals. So you can only travel 10 times before you automatically get entered in the boss fight. So you have like a movement budget before the end of the level. So you have 10 moves to get as powerful as possible by traversing this map here. Now, what I don't like about this is that these require backtracking. And I was talking about this yesterday on stream, which is that backtracking is going to be basically penalizing the player because it's going to cost movement. Now, I could fix that by I could just say, oh, when you visit a node that you never visited before, that's when you get the church's like sort of eyeballs on you. But then you're just doing busy work of backtracking, which doesn't really have a gameplay effect. I want every move to have some kind of effect on the gameplay. So something like this becomes bad because if I want what's up here, I gotta take one movement cost, another movement cost, and then another movement cost, then another movement cost, just to get back to where I can actually visit a new node. And I don't like that. So what I might do is I might detect leaf nodes and forcibly add a shortcut from the leaf node to another node. So basically just make sure there's no leaf nodes is basically what I would do, I think. Which should be relatively simple. Yeah, because the only thing that would need to happen then is I just look at the leaf node, I look at whichever edges were excluded that are connected to that leaf node, and I just pick an edge to add back. Because as long as a node has two edges connected to it, that means that there's a loop, right? I think that's logically true. So if a node, there's guaranteed to be a loop if a node has two edges connected to it. Which means that theoretically, that's less opportunity for backtracking, right? So if I added an edge from here to this one, now I can plan my movement such that I go here, 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 and here. That still might incur a backtrack, but there's other ways to avoid it too. Like I could go down here, 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 and then back down to here. So anyway, there's probably going to be some backtracking, but I think as long as I have to give the player options to either minimize or give them a way of planning their movement that doesn't involve backtracking, I think that would be fine. Maybe use the game tab and select it with the input selection option to see if the node is first or last in the scene. That's a good idea. It is neither. It's the second node. So this is the first color rect. I wish I could show this. So I don't know if you can see that orange outline there. That's the first color rect, and this is the second color rect. That's very interesting. I might have to enter the debugger and see if there's any nodes that don't have edges for some reason. That shouldn't be the case. There shouldn't be any nodes with no edges, but I'm gonna have to debug that. You might need to check and remove any disconnected nodes for safety anyway. It's a check I'd put in there to be absolutely sure. Yeah, I mean, I think that's a good idea, but I was not expecting there to be any disconnected nodes at all. I wonder, let me do this. I'm gonna get rid of this add shortcuts here. I'm gonna see if it's still a problem. Yeah. It's still a problem there. Offset node positions randomly. I wonder if that has always been there. Let me see. I wish I could show this at the same time, but let's hide that one. Position. Huh? I'm gonna hide all these. Interesting. Which game are you working on currently? I need to perfect the elevator pitch. Himanshu. This is a collectible card game, grid inventory management auto battler with a necromancy / medieval science / alchemy theme, where you collect cards that have various abilities, but you can also alchemize the cards to augment them with abilities that they typically can't have. And it's an auto battler, meaning that you will just like set up your board and you'll fight an enemy board, and then whoever does the most DPS or healing or whatever will win. I've seen some algorithms that remove all unreachable nodes from the origin node as a final step. Maybe that random node is your code is not in the right position. Yeah. Blueprints has a mechanic like that. You have a game tab at the top with the script in 2D. You can show them at the same time with the game tab, but that depends on your preferences. Yeah, I don't like the game tab at all, really. I don't like it. But I guess that would help to show the remote scene tree. But this is only a problem with offset node positions randomly. I don't understand where that's coming from. I don't understand where that's coming from. All right, let's do this. Oh, no, I'm selecting the cursor. No. It's fine. It's like... It's this one here. I don't know why that's happening. I wish I knew. The triangulation shouldn't be creating any... The triangulation shouldn't be creating any orphan nodes. That's the part that I'm confused about. I mean, yes, I could fix it by just detecting a node that has no connections and like removing it from the map. But I'd rather get to the bottom of like why that's happening in the first place, you know? There might be a problem in here as well. My connections here, my node connections are bi-directional by default. I wonder if that's creating double the amount of edges that it should be. Yeah, I think that's probably a problem. So I shouldn't make my edge connections bidirectional by default. They should just be one directional. That should reduce the number of, so this is actually going to be wrong now. That might be part of the problem. So basically, I think the minimum spanning tree is expecting an edge to just be like a singular representation, but I was creating two edges from node A to node B and then node B to node A, but I think it only needs one representation for that edge. And this edge count now is 19. It was like 58 before, so that's definitely an issue. So let's do this instead. Let's do divided by 3 divided by 2. That might have fixed the issue, actually. Nope, it's there again. Oh my gosh, what is going on here? Oh, I'm not adding shortcuts back in either. Hello, can I get help? How do I make an indicator balloon that points to my character? That is a good question. I've done it before. I did it in Gunforged, but it's kind of math heavy. I would ask ChatGPT. Where is this coming from? I mean, this doesn't, yeah, that's not really helpful. I know that this is here erroneously. Yeah, the multiple option. So I don't know what's going on. There's like a ghost node here. I guess the next step is to maybe debug. Scenes UI map test map. Let's try it out. Map nodes. I'm just going to click through here and find the one that doesn't have connections. There's one. So yeah, there's a node in here that doesn't have any connections. Why is that happening? Does that happen? I mean, this shouldn't do anything. Why is it so close to the start node too? I don't understand. How is that happening? I don't understand that. How is it generating an extra node with no connections? Let's get rid of the shortcuts. Let's get rid of this. So weird. I created a map generation last week, but I did use rectangles, which are easier because they have some structure. Yeah, that's a good point. That's a good idea. Map nodes. It was like element 14 before. Yeah. What in the world? I don't understand. So there is a node in here. It's just because it's not offset. I wish I knew where that node was coming from. I think what's happening probably is that maybe there are 2 points with the same value in here. So there's a node being created on top of another node. And that's causing the triangulation to mess up. So it's not creating edge connections between those two nodes because they're on top of each other. And then when I apply the random offset, that's what's making it visually apparent that there's a node there that's not connected. So how would I check that? How would I check to see that all the nodes have unique positions? Well, let's just go here. This is probably going to be painful, but we'll just see if I can click through and recognize any nodes that have the same position. I mean, the start dimensions divided by 2, 538 divided by 2, let's see. 269. There's 269 right there. So let's see if I can find another node. It was like number 13. 269. That's fine. 269, 163 is what I'm looking for. There it is. There's another node in here with the same exact position. So apparently this is not working. So there's a node being added at the same location as the start node. That's probably what's happening. So apparently this check is not working. Potential cells.add. Why is this not working? Skipping. I don't understand. Let's see. Sanity check to see if you see a node with no connection on the map. Is try to connect it or even remove it. Well, the thing is, I don't want to just band-aid like remove it. I don't want to band-aid just remove it because that's ignoring the core issue. I'm going to take a look at all the list of potential cells here. 3, 3 should not be a potential cell. Is my get cell center correct? Yeah. Three, 3 is the center of a 5x5 grid, right? Should be. Oh, wait a minute. No. Let's run this again. If one indexed, yes. Oh. That's the problem. It's 0 indexed. Okay, fixed. Thank you. Oops. Okay, that should fix it. That should fix it. All right, Phantom node destroyed. Off by 1 error. Yeah, that was an off by 1 error. I don't know why I was thinking that the grid was 1 indexed. But obviously I was not correct. Okay, that fixed it. I knew there was, yeah, there's something weird happening because the triangulation should make sure that all of the points are connected. So it's like the solution of like, we'll just get rid of the nodes that have no connections. I could have done that, but there was a deeper problem in play that I wanted to fix. Okay, so now we have some good looking maps here. I think, I mean, obviously I can tweak this stuff and play around with it, make sure there's no leaf nodes and whatnot, but I think the next thing to do is actually to try to start getting some of this functionality working where I can start here and go and select things. So I think the next step, I might actually start doing like an art mock-up of the map to make sure like all the sizes are correct. I don't want to go too far down this path. This might be too many nodes actually, because if I want to draw icons for all the different event types, then I need to play around with the sizing and like what the paths look like and stuff. So I might work on the visuals next. Try to get that feeling and looking good. And then, yeah. We'll go from there, I suppose. I'm going to go and delete this from the game UI. Test map. Did I add the MST in this work? Yeah. I think so. Or no. Fixing things. I'm going to do this. To do needs to be finally bi-directional. Cool. Classic off by 1. Yes, indeed. 2 hardest things in programming: cast invalidation, naming things, off by 1 errors. Yeah, ain't that the truth? The hardest part of programming is sustaining of how fun it is. Now with AI, things are being sped up faster, but at the same time can cause complications. Yeah, I guess that's true, yeah. I definitely recommend that beginners don't rely on AI too much because you do need to know what's happening, but I've written a minimum spanning tree implementation before, so that's something that I really am interested in knowing a lot about. So the AI just did the busy work for me, which is great. So yeah, that's going to be it for the stream today, though. Thank you all for watching. Thank you all for being here. And yeah, I think it's turning out good. So we'll see how it develops. I'm looking forward to actually getting this functional now that it's being generated. But yeah, again, if you want to support my work, you can check out the links in the description below. Those are all the ways that you can support me. And if, well, let me think. Oh, the other thing is I have another code review video coming out on Saturday. And I'm also working off stream on the new multiplayer course, the online multiplayer course. So stay tuned for all that stuff. And thank you again for your support. And I'll see you back here tomorrow at 10 a.m. Eastern. All right. Have a good day, everyone, and bye-bye.